Okay, so we're gonna go over how to solve part 1 of the project, and to do this I advise you to go over how to make functions on Matlab, which is already on the YouTube channel. So the first thing is that before you try to complete part 1, part 2, or 3, you should try to make the functions that are the bottom of your code first. So we see that the Arrhenius function is down here, and Professor Driscoll already did the template for the function itself. So what you have to do now is complete it with the equations for Vg, Vm, Vn, and so on. So I'm going to make just one of the examples, and then you can do the rest. So the first thing is I would advise you to do an RT variable. This is going to make your other calculations a lot simpler. So it's just going to be the value of the R constant, which we're going to take as 1.987 times 10 to the negative 3. And then your temperature, and all of the equations are given for Kelvin, so you're going to have to add 273.15 to all of your temperatures. So now that you have your RT, then you can look at the equation on your first page of the instructions, which tells you that the parameter is equal to A times the exponent of negative E over RT. And so what we're going to do is we're just going to do the first one, which is Vg. If we look at the table of parameters, we figure out that the equation for Vg is just the exponential of 35.77 minus 22.6, and then this divided RT. Please, again, as before, don't forget to add the periods before your division sign. This is needed for this case because t can be a vector, and we want all of these to be done element-wise. So anytime you're dividing, don't forget to add the period. Then you're gonna have to do this for all of the parameters here. So this is how you do Vg, and then you do the exact same thing for Vm, Vn, Kg, Km, and so forth. The only thing that is going to be the same equation for all of them. The only thing that is going to change is your A and E parameters that you can find on the table on the second page of your of the PDF document. So once you've completed the function, then to do part 1, you go back to the first part on the template, and then the first line of code that they provided you is t equals linspace 0.2300. So what this means is that Matlab is going to create a vector of 300 points between 0 and 20. This is a very easy way of making very large vectors with very simple coding. So they're all going to be equidistant. In this case, it doesn't really matter, but it will later. So now what he wants to do next is to find Vm and T and find Km and T and then plot them. To do this, you're just going to call the Arrhenius function. So what you do is you can just simply copy and paste your function here. And basically what you're saying is you're giving T a value, which is a vector between 0 and 20 containing 300 points, and then that's your vector t, and then you're going to calculate all of these parameters for each one of those temperatures. That's why it is so important to not forget the periods when you're doing the operations. Otherwise, you're going to end up with vector multiplication, and the numbers are not going to match. So now after you do this, you can just use the simple plot equation that we've used before, and then just plot the parameters that are asked. So in this case it's Vm and Km, so you can just simply say plot. Of course, in the x-axis you want the temperature because you want to see how these parameters change as a function of temperature, and you of course expand an exponential type behavior, either decreasing or increasing depending on the sign of your constants a and e. So in this case we're going to do plot t, and then we're going to plot in this case for example Vm, And that's all you need to do. So now you have to add labels, add titles, and then do the same thing for KM. And that's all you need to do for part 1.